Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Lumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Hi, everyone. Welcome to another edition of the AI Innovation Space. We have an amazing guest here with us today. His name is Jack Ding. Hey, Jack, how you doing?
Hi, Yanu. Thanks for having me here.
Awesome. And I also have my co-host with me, Todd. Todd, how you doing today?
Very well, thanks, Yana. Looking forward to today's episode.
Same.
So, Jack, we're interested to discuss your background. I know you have a PhD, how that led to your interest and work in the machine learning and artificial intelligence space. Could you expand on that for us?
Yeah, sure. Ever since I was a kid, I was interested in math. Started doing a PhD in pure math at the University of Toronto. My field was called symplectic geometry. It was based on physics, classical mechanics, and that developed into its own branch of math. My advisor was Lisa Jeffrey. She's a great mathematician. I think she's a Royal Fellow as well. During my PhD, aside from doing my thesis, I got interested in machine learning. Actually, after seeing the success of AlphaGo, I grew up with the game of Go as a kid. My dad always played it. So I thought it was very impressive that, an AI sort of had a breakthrough in what was reputed to be the world's most complicated board game. I think before 2016, no one ever thought computers would ever be able to beat, human masters, but AlphaGo did that, and that's what really got me into AI and machine learning. So towards the end of my PhD, in addition to sort of learning the concepts by myself, I took a deep learning course at my university. And there I learned some nice tips and tricks from an amazing professor. His name is Vardan Papian. I think he is currently working at University of Toronto right now doing AI research. Yes. Shortly after that, in 2021, I graduated and I began my transition into industry.
I see. So this game that you were talking about, what's the name of the game again?
Go. So to the Western world, Go is the Japanese game for the game. The Chinese name is Weiqi, which means the surrounding game. So basically, the rules are very simple. All you do is put stones on the board and you try to surround your opponent. And whoever has the most territory, like they've surrounded, that player wins. And despite the simple rules, it turns out the game is very, very complicated. I mean, magnitudes more complicated than chess. So for a long time, people thought there was no way that AI was going to be able to learn such a complicated game, which makes the recent deep learning advances all the more remarkable.
I see. All right, thank you. So were there any courses that you took during your studies for your PhD in math that you feel are particularly relevant for machine learning jobs and industry?
Yeah, let me start with the basics. So any sort of data science or machine learning job you're likely to do, that involves good understanding of calculus linear algebra. So I don't think you need to specialize in anything. This is offered as part of the core curriculum for math in the undergrad level. In addition to that, it's also important to know some basic probability and statistics. And I think that's also something most people learn in their second or third year undergrad. As for more specialized topics that you would encounter during your PhD, I would say that, of course, you will get a deeper understanding of probability and stats, of course. But I think another topic that could be interesting is optimal transport. So I've actually briefly touched upon this in my blog, but it's a new direction in machine learning where, because we're trying to always compare, training data sets and testing data sets. And when you have these data sets, you need some kind of notion of how close they are or how similar they are to each other. The new way of thinking about it or approaching it is through the theory of optimal transport. And that is a field one can study during a PhD, for example.
I see. All right, thanks. Yano, you have any follow-up questions on any of that?
Yeah, I do. So, Jack, if you were going to say what was the most important book that really helped you to get a grasp on calculus, what would that be?
Oh, okay. So this is a funny story because there's actually a lot of calculus books out there.
Mm-hmm.
So for machine learning specifically, I should make a distinction between like single variable calculus and multivariable calculus.
Mm-hmm.
I think what's more important for machine learning is multivariable calculus because most data sets are going to be, more than one parameter, right? So for that, could go with the standard like Stewart textbooks of
Mm-hmm.
multivariable calculus. Yeah. So I think I was in the math specialist program, so I used like more fancy textbook. But I guess for machine learning specifically, you don't necessarily need the fancier one. You just need the standard one,
Mm-hmm.
and that should give you what you need. And for linear algebra, well, when I was still in the math world, people used to say there is no good linear algebra book. I think honestly these days it might be more helpful to even just look at lecture notes from universities. I don't think you really need like a standardized textbook in order to learn linear algebra. Because as machine learning, it might also help if you do some coding or experiments. So like there's a lot of linear algebra libraries out there. Like so I know for C++ there's eigen, and then for Python you can use standard NumPy or PyTorch libraries. So just play around with matrices, vectors. I think that would help you learn better.
Excellent. So thank you so much for sharing that. I think one other question that I had then was, how do you take all of this different knowledge and apply it to the metaverse, right? So
Right.
we're discussing, I think you work at Metaverse Mind Lab.
Yep.
Can you discuss a little bit more about how AI solutions are actually working in that specific space?
So unfortunately, I can't go into the nitty gritty details, but I can give like a high level overview.
Oh, yeah, of course.
Yeah. So we know that VR is sort of a fledgling emerging field right now. So I guess not a lot of people have thought about it too deeply yet. But maybe first I can say something about how it's different from what we're used to, right? So first of all, there's a different kind of data that's in VR that's not really being tracked in other situations because, well, think about what you do to enter the VR world, right? You put on a pair of goggles or glasses. And that's actually really important because that's the main interface with the user. So instead of clicking a mouse or like pressing a key on the keyboard, you're interacting with the virtual world through this goggles. Something like gaze detection is really important. So in the VR world, we like to know what the user is looking at specifically. And of course, you might also say this is important in 3D games like, first person shooters as well. But there, it seems like that only matters if you're shooting something. If you're just looking at something, no one cares what you're looking at. But in VR, that's actually really important. So that's something, an additional piece of data that can be leveraged in this kind of space.
I see. So can you explain a bit more about what motivated you to get involved with AI in the metaverse? Was this something that you had done?
You mean with my current company?
Yeah. Was there something that drove you to this particular role with your current company?
Oh yeah, I can explain about that. So when I got out from academia into industry, I was looking for exciting applications of AI because I know, especially right now during this AI wave, I know there's a lot of powerful things that AI could do if applied correctly, of course. A few years ago, I guess before this super huge AI boom in the last few months, I think VR was also had a huge wave. I think I first heard about Oculus also in 2016, the same year AlphaGo beat the world champion. So back then it was sort of like these two trends competing. But now it sort of seems like the AI wave has completely eclipsed the VR wave. But I think if people focus just on AI, like the language models, and start to forget about VR, I think that's actually a mistake because I think VR is a field with huge potential to grow, especially since it's in the early stages. I think actually more and more companies are starting to use VI in their applications and in their companies. There's not as much news about this as the AI models that are making waves right now, but I think it's steadily growing and it will be the future. So I thought I wanted to jump on this train while it's still early so I could be part of this change, I guess.
I see. That makes sense. So I know you can't get into all the details about what you're doing with Metaverse Mind Lab, but can you just give us a little bit more about what exactly are you using AI for, like kind of at an overview level with the VR? Like how does the sensory and visual inputs that you're getting with VR allow you to make some sort of a decision with machine learning?
Right. So again, I will try to keep it high level, but basically there's a lot of problems in video games, especially VR environments, because a lot of people are very toxic. So for example, like a lot of people, especially female players, have reported instances of virtual harassment, and this doesn't hurt any less than harassment in the real world. So an application of AI would be to try to detect instances where someone's being harassed in the virtual space. This is sort of a different scenario than if you were just looking at some trolls spamming hateful messages online using text, because this is an entire 3D world and we have to take into account different sets of data and run a model based on that.
I see.
Excellent. I had another question around computer vision and VR, right? You had mentioned amazing use case on privacy issues that occur in the VR space. Are there other privacy issues that you think that our audience should pay a particular attention to? Are there like discriminatory issues that exist in the VR space? And are there solutions out there, or do you have any interest in solutions of that nature?
Yeah, thank you for the question. I think you bring up a very good point. I would like to bring about the examples of Fortnite and Roblox. So if you ever play these games, you know that these games have a creative mode. And what happens in creative mode is that the user or player can basically create their own mini environment and they can put whatever they want in it. And sometimes people might use that to spell out hateful symbols or hate speech. So they're not typing it out in text, but they're sort of arranging objects in such a way that, okay, you can see the hateful symbol. So that is one potential problem. Potential problem is copyright. So because users are free to make their own environment, unfortunately, a lot of users might copy or rip off assets from other users without their knowledge or consent. And so copyright and hateful symbols are two problematic use cases for the VR space.
I see. So I'm kind of interested in your thoughts, Jack, as to how you see the metaverse and the application of machine learning to be used with the metaverse and VR to kind of help transform and maybe change the way that humans interact and do their jobs and like interact with the world. Do you have any thoughts or ideas around how that's changing and, will continue to change in the future?
Yeah. So Todd, I'm glad you mentioned doing our jobs, because that's actually one of the main applications of VR right now for enterprises. So a lot of companies like Bell and Canadian Tire, they're hiring a lot of new employees, and new employees need to be trained, right? So traditionally, they would have to take them to a warehouse or some kind of constructed environment for them to maybe climb down a ladder or install a cable. And not only is this costly because you have to rent out a whole space, maybe like even half a street sometimes, but there are also potential hazards, right? Like, what if someone gets electrocuted? What if someone falls down the ladder? These are all a pretty real risk. However, if you use VR, you can set up this whole training environment virtually. So this way, you don't have to take them offsite to a specialized training area. You can take the new employees into the VR room and have them do the training there. And of course, some tasks are very simple. So, for example, you want to check whether the light is turned on. You want to check that there are no gas leaks, for example. These can all be simulated pretty successfully with the virtual space. And for a lot of it, it feels like it's the real thing. You're walking through a room with 360 view, and then you can turn on and off switches. You can interact with objects. And of course, if you want things to be realistic, you can always have artists do design and draw better assets. So this is a way to help companies train new employees and lower the costs and the potential dangers of doing so.
It's very interesting. I definitely see the application there. So, do you kind of see that that's kind of where the industry will be heading? At some point, we'll be seeing a lot more virtualized trainings at companies and governments across the world.
Yeah, for sure. I think it's already happening. Again, probably hasn't received a lot of news coverage, but I know for sure that Bell and Canadian Tire, very big companies, are already doing this. So sort of, the future is already here.
That's awesome. Also, I wanted to ask a few questions about tooling. What are some of the basic tools needed for someone who would love to get into the metaverse and development in the metaverse? Any suggestions on what languages, environments, things like that?
Yeah, great question. So actually, the first barrier to entry, I would say, is getting the goggles, the VR headset. So it's not really a cheap item, but that's really the first thing you need. So once you get the headset, then you will need a game engine. So it might seem weird that I'm suggesting game engines, but game engines don't have to be just for video games. They can also be used to set up, sort of a virtual environment. So if you use the most popular ones like Unreal Engine or Unity Engine, there is an option in these engines to export as VR. So you set up your virtual environment and then you export it to VR, and then you wear your headset, you can enter it. As for languages, because I'm talking about the two most popular engines, Unity uses C Sharp and Unreal uses C++. But of course, what you can do, I think experts will know about this, is that you can sort of communicate between languages. So what you can do is, let's say you want to use Python more, right? What you can do is you can have your virtual reality app log something in a txt file or a log file. Basically, you log all the important stuff you need, and then you can have a Python app, the language you're familiar with, to pick up those logs and then interpret it the way you want. So I would say, like, of course, it's ideal to learn the native languages like C++ or C sharp. But if you have another language, you can always sort of communicate between them. So I would say it's not the most important thing, but yeah, C++ and C sharp are useful in these circumstances.
Got it. A follow up on that would be, so let's say, for example, one started, I'll put it this way. I know that working in 3D space versus 2D space could be a challenge for people who may think that they don't know a lot about art, because they just make the assumption that it's all arts and stuff. I'm aware that you can use models from Turquoise and is it Turbo Squid? Sorry, Turbo Squid, and
Mhm.
all the different platforms. So, can you touch on how, if any of our viewers would need to just make a hump into or deep diving into this specific space, what they need to be up to speed with so that they're better able to create and build environments?
Yeah, our team and our company does hire a lot of 3D artists to help us set up all these scenes and environments. So you're right, art is very important. But then again, art is also important just with 3D games in general. But what is different about VR specifically is sort of the user interface. So I think people who want to enter the VR space should be aware of the fact that, so again, you're not inputting things using your mouse, your keyboard, or any of these traditional methods, or touch screens even. What you're doing is communicating with your eyes and your controllers. So what you can do with your controllers, you can sort of think of it like a Wii controller for people who have played those kinds of games. But it is sort of more than that, because usually in VR applications, there's an option for the user to teleport. Because if you imagine, like, there's a huge open world, someone set it up. You don't want to have to waste time walking all the way from one end to the other. So most VR games and VR simulations will have a teleport feature. And if you see that for the first time, you might be a little freaked out. But it is something that you should be familiar with if you're trying to enter VR. So basically, you interact differently and you move around differently.
Thanks for sharing that.
Yeah, thank you so much. Well, one thing I'm wondering as additional follow up here is about the environment and the computer requirements. Do you require like a lot of hardware that's very powerful to be able to operate with these environments and virtual reality space and these 3D spaces?
Yeah. So I would say the hardware requirements are the same hardware requirements required by the engines that I mentioned. So basically Unity and Unreal. And I think game developers will already be familiar with this, but Yeah, especially when you import a lot of assets, you need a lot of memory, you need a lot of storage, you need a good GPU for rendering things. So of course there are some pretty strict hardware requirements, but that's for the development side, right? When you're actually using it as a user, you're putting on your goggles. I think most VR applications are built for the standard VR headsets. I mean, VR headsets are not like PCs where you could have a very low end PC or you could have super expensive custom made high end PC. I think all the VR headsets are pretty standardized at this point. So if you're just on the user side, you shouldn't have to worry about hardware. But if you're on the development side, obviously the better your PC is, the more smooth you will be, your development process will be. Yeah.
I see. That makes sense. Yano, anything else you have on the metaverse topic before we move on?
Just one more thing. So I also understand that when you do bring things into an environment, there are a few things that one needs to be aware of while working with those images or those, within that specific environment. Can you touch on some of the critical things that are important for someone who is trying to get into this space to be conscious of or cognizant of while they're using the environment?
Okay, so here's a funny scenario that happened in the Roblox game I mentioned.
Right.
Because these games sort of give the user more abilities and more freedom to interact. Sometimes they'll have the user be given a spray can. Just like in real life, people will draw a lot of graffiti. But I think one very egregious case that I've seen a video of is there was a chat room. It's just a chat room. There's no gameplay or whatsoever. It's just a place for people to meet. And because users were given this spray can spray paint ability, people just started spraying all over the place at waist level of their avatars. So basically, the eventually the whole room got clogged with just lines. People sprayed all across the room, and basically no one could see anything. So that's something that people should be aware of, is that the more freedom the VR app allows for its users, the more of these strange scenarios you will see.
Thanks for sharing.
So I know you've also done some work before coming over to Metaverse Mind Lab with IntelliSense.
Yes.
And we were interested in hearing a little bit more about that, and particularly regarding those adversarial machine learning models for security cameras that you worked on. I'm not sure if you can share anything regarding that topic.
Yeah, I can share a bit. So basically, you bring up the this class of models, which are called generative adversarial networks, or GANs for short, GAN. And basically, this whole class of models got started out with the seminal paper General Adversarial Networks by Ian Goodfellow. I think it was written in 2014. So the idea is, instead of training one model, you train two models at the same time. So what is the point of this? Well, one of them is the generator. So this is the model tasked with generating whatever you wanted it to generate. The other model is called the critic.
Or the discriminator?
Yes, or the discriminator, yes. So there's a very interesting dynamic between the two. So the generator tries to fool the critic, or at least try to convince the critic that what it's generating is real and it's a proper image that you will want. The critic, on the other hand, tries to be the best critic it can. It tries to tell reals from fakes. And because of this sort of adversarial competition between them, they actually are able to train together and become better at generating images. So I should mention that most use cases for GANs can be considered as a sort of image translation problem. So for example, let's talk about this use of security cameras. I don't know if you guys have watched those police dramas or spy dramas, but when I was a kid, I was always amazed that some detective would say, okay, this image is too blurry, this camera is too blurry, zoom in, right? And when they zoom in, they can see the license plate number or the guy's face, right? So when I was a kid and I saw this, I laughed it off because, okay, yeah, this is all science fiction. You can't do that in real life. But now you sort of can with these guns, right? So in this particular use case, you're trying to do what's called super resolution. So you're trying to take a low resolution image and translate it into the domain of high resolution images. So you can think of it as like a translation problem. Just like you're trying to translate English to French, you're trying to translate low res to high res. And now, if you think about the roles of the two models, the generator tries to generate convincing high resolution images or super resolution images. And the critic tries to tell, okay, is this image a real enhancement or is it just something the generator made up? And in this sense, the GAN model is used to generate or enhance low resolution images into high resolution images.
I see. I think that's an excellent explanation you gave there. I think Yano and I both have experience with those type of models as well. So one thing we're also wondering is kind of your thoughts as to the intersection of machine learning and computer vision. I know you were doing some computer vision work as well at Telesense. And if you can expand on that and kind of your thoughts regarding the two different topics.
Yes. So when I was at Intellens, another, I guess, intersection or application of GANs is anomaly detection. So first of all, I think this kind of use case appeared in medicine when people were trying to detect, whether there's something abnormal about the patient's body through, CT scans or X-rays. Of course, you can use this for other applications as well. So if you're trying to detect, whether someone's being robbed, whether someone's house is being robbed, you would check their security camera for anomalies, basically. So, on a normal bright sunny day, and you might have a security camera that's looking out the house's window, and on a normal day there's usually nothing there, so everything sort of keeps still. But let's say a thief is trying to enter your house, then there would be a huge figure in the middle of the camera, and that would be classified as an anomaly. And so GANs can also be used in this context for anomaly detection. Yes, so that is another thing I did at Intellens. But if we're talking about, I guess, more cutting edge intersections between AI and computer vision, I know that recently NVIDIA has developed some new algorithms in their environments. So basically, a lot of video games right now are trying to do what's called ray tracing. So ray tracing is an algorithm which sort of simulates actual physical light rays in the real world. And by doing this, you can have more realistic lighting in the video game. So basically, if you pass a puddle, you can see the reflections. Or if you pass through, a fuzzy surface, it can sort of diffuse light around. So basically, they're trying to make their games like photorealistic. But the downside of this ray tracing algorithm is that because you have to simulate every single possible light ray from every single direction, it is very computationally expensive. So how AI can help in this is that for certain areas where you might not want to calculate every light ray, you can have the AI sort of learn what the lighting should be there. So you want to do partial computations, not every area, and then have the AI fill in the rest. And this speeds up computations by a lot. And basically, this is sort of the way of doing it right now, is to use sort of AI assisted computation.
I see. Very interesting. Yeah, that definitely makes sense to have AI assisted computation to speed things up. Just one thing I think you briefly touched on was the anomaly detection for medicine. Can you just expand on that again a little bit more?
Oh, yeah. So we still use a gun, but it's like a different kind of version. So instead of generating images, it generates like an anomaly score based on the images that it's trained on. Basically, an anomaly is detected if the anomaly score passes a certain threshold. And this is a hyperparameter you can set for yourself. But basically, this is another security camera application. Yeah, like I mentioned, it detects whether some fight has broken out or someone's stealing something, or maybe there's a commotion somewhere. These are the possible use cases.
I see. All right, thank you. So we're also interested in learning a bit more about the writing that you do on your blog. I know you mentioned that briefly a bit earlier at the beginning. Can you
Yeah.
expand at all on what you're writing about on there?
Yeah. So again, when I entered industry, I knew that in contrast to the pure math I was doing in academia, machine learning was going to be a very hands-on experience. So I thought that in addition to reading articles and papers, I also wanted to sort of train myself, practice by explaining the ideas I've learned in a readable format, and also practice coding them. And that's how I got the idea to start a blog series. And I usually try to aim for a mathematical explanation of the underlying algorithms. And if I have time, I will provide a small experiment or a code sample where I test out this algorithm. And in addition to those, I also try to give the history or motivation of how this algorithm came to be, how it came to be adopted by the industry, and who's using it, what it's trying to solve, and so on.
I see. Thank you. Have you ever thought about publishing any of that in a more formal format?
Yeah, so I actually do try to write it as formally as possible, but I guess I could think about maybe cross-posting it on maybe Medium. That's something I've thought about.
I see. Yeah, a lot of people use Medium. Yana, do you have any other questions at this point?
So one more question for you. Where do you see MR going in the future? We've been discussing VR, but how
Yeah.
about AR, MR?
So I'm pretty sure everyone's heard about all the big advances recently with the large language models and stable diffusion. So I think one pretty obvious and natural extension would be right now we have text to image generator, right? In the future we would have text to 3D generator. So it would almost be like the holodeck on Star Trek, where you just ask the computer to generate a scene or an environment, and the AI would figure out how to generate it. So, for example, I want to say, give me a national park with a picnic table, and the AI will know to generate a 3D scene with a table, with some trees, with some green grass, maybe a creek, some birds. So that's the next logical step. I think so. So that's all more on the product side. I think more theoretically, I think more and more mathematical theories will be applied to machine learning. For example, one of the grad courses you take as a PhD student is algebraic topology. And basically, this field sort of extracts information about higher dimensional objects. And as you can imagine, a lot of data in machine learning is in a very high dimensional space. So, for example, bird embeddings, I think, are in 786 dimension space, right? And because the dimensions is so high, it makes the data possibly very complicated. But with algebraic topology, you can extract some low level quantities and sort of statistics from it. And so this is an area called topological data analysis. And this field has actually been around for a while, but it hasn't really intersected or interacted with machine learning all that much. And I think going forward from this point, there will be more of a fusion between the two, especially when we get to text to 3D, right? You're
Right.
gonna have 3D data, and you're gonna need topology there for sure.
Yep.
I see. That sounds very interesting and definitely something we'll see in the future. So kind of, maybe you already covered on it, but I'm kind of wondering, is there any areas in the machine learning or computer vision type of spaces that you wish you had time for to work on, or you kind of feel that would be beneficial to get more work towards to kind of advance things in the future?
I guess I have a personal bias here, but I would say something related to what I mentioned with NVIDIA's doing with AI assisting ray tracing computations. I think a huge part that's exciting about this intersection is that you can use AI models to create, more beautiful and realistic graphics. And I think that's something that's really interesting to me.
Sounds great.
That sounds really good.
One final question I have is there any challenges that you wish you could share with our audience regarding anything you've encountered over the years of training machine learning models?
Yeah, I would say probably the biggest challenge is processing the data because I think a lot of people entering machine learning might have had their first exposure to AI through maybe Kaggle competitions. And the thing about Kaggle competitions is that the data that's provided to you is already very clean. So then it's just a matter of, trying to find the best model, right? But I think in industry settings, usually even the data you get is very messy. So for example, you might have text data, image data, and audio data all at once. And they're in such different domains, it doesn't really make sense to put all of them into the same model. So then you have to consider, okay, do you have to standardize them somehow so that they do fit in the same domain? Do you have to use different models for each and then put them together in an ensemble? These are the things you have to think about. And often you can sort of transition between the two modes. So, for example, let's say you're trying to design an audio model. So, all the data you have will be audio files like MP3 or WAV files. And you might think, okay, how do I analyze this? I'm going to analyze it as a time series, like a stock chart, for example. However, you can also leverage all the advanced image-based models by converting the audio into an image file. So how do you do this? You do this by drawing out its spectrogram. So a spectrogram is an image of the audio file that basically encodes its frequencies and amplitudes. You can think of it like a heat map. So the louder frequencies will have a brighter spot on the heat map, and the frequencies that are not really there will be darker shade. So what you can do is you convert the audio into a spectrogram and then run an image-based AI model on the image of the spectrogram. And there's a lot of success in doing this instead of working on the audio file directly. So that's something to be aware of. Like you might think you're dealing with like text data or image data, but the data you actually want to feed into the model might be something that's totally transformed.
I see. Very interesting. Yano, any further questions from you before we end here?
I'm good.
Well, we really appreciate you taking the time, Jack, to
Yep,
meet with
you.
us today and offer your clear explanations on some of these interesting topics.
Yeah, thank you guys for having me.
Yeah, thank you so much, Jack. We really appreciate you coming in to have this, great, insightful conversations with us. Really, really grateful.
Yeah, it was very nice having this discussion with you.
All right, thank you all so much for joining this edition of AI Innovation Space. We're happy to have you on and looking forward to the next session. Thank you so much.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.